right, so we're on to reflections, and I brought over what we looked at earlier, just cuts out time. So what do I do with this? What do I do with this here? Let's do blue here. All right, so if I'm flipping across the x-axis, then y equals negative f of x. And that's essentially what we wrote earlier. Now, if I'm flipping across the y-axis, if I'm flipping left to right, and you want to note that it's left to right because it's not always the y-axis or just the x-axis. So I would do a negative inside of the function. So my x's get the negative, specifically my x's. All right, so keeping that in mind, for the x-axis, it's always pretty simple. So it's just negative f of x. Right? So what does negative f of x represent? This equals a negative times x squared plus x minus 2. That means every sign changes. So I get x squared negative minus x plus 2. All right? What does that look like with a rational? So basically, negative f of x equals negative 2x plus 3 over x squared plus 2. So the whole function gets a negative applied to it, basically. Now, what does that look like? What does that flip look like when we're flipping left to right? So here, we want to be mindful and careful. So it's only the x terms get the negative. Only the x terms get the negative. So what does that look like if only the x terms get the negative? That looks like parentheses. So parentheses here, negative x squared plus negative x. And notice my constant, my number, is just the same. It doesn't change. We only apply this to the x terms. So I have equals, we get x squared minus x minus 2. Look at the bottom. So we have same thing, f of negative x, and these are all essential. Okay, this is equal 2 times negative x plus 3. Didn't change my constants. Right here, negative x squared minus 2. You can simplify that. I think it suffices to leave it that way, but negative 2x plus 3. X squared minus 2. So big difference there. So when we're thinking about stretches and shrinking, dilations, that's going to be next. I'll copy that over.